This is Naming Acids by David Ha. In this video, I'm going to be demonstrating how to take the molecular formula for an acid and give it the proper name. So let's get started. Okay, so first we're going to start off by defining what an acid is. An acid is a substance that has a pH value that is less than 7, and acids are identifiable by their sour taste.
So I do believe there has to be a experimentation portion of this project, and seeing as my assignment is about using formulas to name acids, I wasn't sure exactly what my experiment would be, but this is it. So we know acids are generally sour, so I'm going to test a couple of things to see if they are acids or not. So first up, I have this carrot, and I'm going to eat it and see whether it is acidic. No, it's not acidic. It's not very sour. All right, that's good. I'm gonna write that down. Carrots, not acids. All right. We'll move on to step 2, which is a small portion of a pickle. That's pretty sour. That's an acid. Alright. Pickle. Acid. Alright. Actually, that's a pretty good pickle. I'm gonna go get another pickle. I'll finish this later. I'm gonna get a pickle.
Alright, well, I'm back and I had my pickle, so and it was pretty good, so we're gonna get back to it. Acids, besides having a pH less than 7, specifically, they are a type of compound made up of a hydrogen ion bonded to a non-metal ion. For example, here this is NO3. Yeah, and then this is HNO3. This is an acid because it's comprised of a hydrogen ion and a nonmetal ion. In this formula, hydrogen is the cation, which means it has given away an electron, giving it a net positive charge, and the nonmetal ion is the cation. The anion, excuse me, which means it has gained an electron, giving it a net negative charge. Acids are easily identifiable in the formula, just based on how hydrogen should be right at the forefront of the formula. So you can see HNO3, that's an acid, H2SO4, that's an acid, HClO2, that's an acid, so I'll start with H. These are not acids because NaCl does not start with H, and H2 is technically not an acid since it is not bonded to a non-metal ion. So even though it starts with H, I just include that one because that's kind of an exception. Just hydrogen by itself is not an acid. Okay, so when you name an acid, you give it a suffix based on the type of anion that the hydrogen is bonded to. The suffix of the anion that is being bonded to, or that's more like the root of the word of the anions. I'll explain that more later. And the amount of oxygen atoms in the anion. So all these together all factor into the name of the acid. All right, so the first type of acid is a binary acid. Binary acids have only one ion, one element bonded to the hydrogen. So, for example, is hydrogen and Cl, which is chlorine, and H and I, which is iodine, just bonded. So it's just hydrogen and one other element. There's just the two, so it's binary because there's two, but two. And so these, when you put them together and they create an acid, you give them the name in the form of hydroblankic acid. So hydrogen plus chlorine is hydrochloric acid, and hydrogen plus iodine is hydroiodic acid. I don't think I pronounced that right, but right. And the other thing about binary acids is they contain no oxygen atoms at all, no oxygen. All right, so oxyacids, hopefully you can guess what those are. It's acids that contain oxygen atoms. So first off, if we have hydrogen bonded to polyatomic ions, which is ions with more than one atoms, so a molecule, and these all contain oxygen. So oxyacids whose anions end with the suffix "ate," so for example, chlorate, nitrate, and sulfate, must end with the suffix "ic." So we have HClO3 is chloric acid, nitric acid, and we have sulfuric acid. So you can see I underlined just the bases that the suffixes that change. So "ate" becomes "ic" in here. Next, we have polyatomic anions that end with the suffix "ite." So, for example, chlorite, nitrite, and sulfite. These all have one less oxygen atom than their counterparts that end with "ate." So let's I used the same three elements, so we can actually go back and look at that. So we have chlorite as ClO2, NO2, and SO3. And if we look back at over here, as ClO3, NO3, SO4. So things that end with "ite" have one less oxygen atom. And that's how you know they end with "ite." And these all must take the suffix "us." So we have chlorous acid, nitrous acid, and sulfurous acid. Yep, and you can see these two over here have one less oxygen than their counterparts on the previous slide. All right. Next, okay, so these next anions are a little bit rare. Mostly you're just going to see ones that end with "ite" and "ate," but I'm just going to talk about these real quick. So there's a few that take the form of hypoblankite, and these are going to have two less oxygen two less oxygen atoms than their "ate" counterparts. So, or if you run, let's just go back real quick. ClO3 is chlorate, but then hypochlorite has ClO, so it actually has two less oxygen atoms. And then perchlorate, which takes the form per-blank-8, has one more oxygen ion. So these are a lot. These are quite a bit rare, but just in case they come up, this one still ends with "ite," and this one still ends with "ate." So that previous rule still applies. This is going to end with "us," and this is going to end with "ic." But you also keep the prefix. So hypochlorite, instead of just becoming chlorous acid, is going to become hypochlorous acid, and perchlorate becomes perchloric acid. So that's so you just need to know that. All right. So in summary, I didn't go over the last two rare ones, but generally, this is where you have is when it ends with "ine," like chlorine or iodine. It has no oxygen atoms, and the acid takes the form of hydroblankic acid. If it ends with "ate," it can have any number of oxygen atoms, well, at least one, and it will take the form of blankic acid. And if it ends with "ite," it'll have one more than this form. So this could have any. So if this has 3, then this one's going to have 4. If this one has 2, then that one's going to have 3, and so on. And this is going to end with blankous acid. And I believe that's it. Yep. Thank you very much for watching. I hope you learned something.